Right guys, welcome to the final live lesson of the week. Okay, this is GCSE Higher here. Okay, when you're ready, have a go. So center it. Have a go at the starter for me, please. Again, lots of difficult stuff in there. It will take a little bit of time, okay? So I'll give you about 7 or 8 minutes to get this done. Okay, once you're finished, we're going to get onto circle theorems, okay? Really important topic, one you really want to nail, okay? It's usually worth 5 or 6 marks, okay? So you want to get it absolutely nailed. Too noisy. Shh, no, shh, 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 no, 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 no. Shh. Shh. Right guys, last 2 minutes and we'll move on. Right then guys, I'm going to go through each of these, okay? I'll try and get through them quite quickly because there's loads of content to get through with circle theorems, okay? So, x squared take away 15x plus 36. Okay, we've got to put this into two brackets. This means factorise then solve. So you factorise it into a double bracket first and then you can solve it afterwards. We've got to factorise this. We've got to look at the 36 and we've got to look at the minus 15. We've got to find two numbers that multiply to make plus 36 and add... Sorry, I got a psycho dog running around, ignore that. Add 15. So they've got to add to make negative 15 and multiply to make 36. Okay, two numbers that do meet both those criteria. I've got x minus 12 and x minus 3. Okay, 12 and 3 multiply to make 36. And minus 12 and minus 3 add to make negative 15. Now, this isn't the whole question done. Still one more step. Okay, we've got to work out what x actually is. Okay, the x value we could use, okay, to solve this, for this to be correct, for it to equal 0, either this bracket has to equal 0 or this one does. If this bracket equals 0, x would have to be 12. If this bracket equals 0, x would have to be 3. So my answer is that x equals 12, x equals 3. Millie, stop. Okay, so I got 12x plus 3 equals 5x plus 31. We're going to take away 3 from both sides first. We should end up with 12x equals 5x plus 28. Then I'm going to take away 5x from both sides. You end up with 7x equals 28. If 7x equals 28, x has to be 4. Okay, right, bear with me 1 second. Stay in there. Right, dog's staying in the kennel. Right, so last one. Right as a single fraction. Okay, this is difficult. Now, what you've got to do, exactly the same as you would with adding and taking away normal fractions, what you do with the bottom two, you'd cross multiply. So I'm going to multiply those together. I've got on one fraction now, 3x plus 2 and 2x plus 7. I'm going to multiply those two together. I'm not going to multiply out just yet. Plus 7. Then on the top, I'm going to cross multiply. So 3x times 2x plus 7. Haven't left myself very much room. Now, minus goes in the middle. And then I'm going to cross multiply this way. 2x, 3x plus 2. I haven't left myself much room at all. What you'll do then, I have to use a whiteboard one for this one. What you'll do then, okay, I'm going to expand the top and we may have to factorize again. 3x times 2x is 6x squared. 3x times 7 is 21x. 2x times 3x is 6x squared. Minus 2x and plus 2 is negative 4x. Now the bottom is going to stay as it is for the time being. 3x plus 2, 2x plus 7. And then all we're going to do, just to finish that off, okay, I'm going to simplify the top. What happens is the 2x squareds cancel each other out. 21x take away 4x is 17x. On the bottom, you can either expand those or leave them as they are. You should end up with 3x plus 2, 2x plus 7. Didn't think that would take so many lines of working, but I put it in anyway. Right then, so back to the page. Right, from here now, recurring decimals as fractions, okay? Very, very easy topic. One you just got to learn. Enough. One you just got to kind of learn as you go through. Okay, 0.04 recurring. I've got to get the first recurring digit over the decimal point. I'm going to put this as an equation first. So x equals 0.04444 going on. Okay, I'm going to get the first recurring digit over the decimal point. So times by 100 equals 4.4444 going on. And then I'm going to times by 10 to get the first recurring digit next to the decimal point. 10x equals 0.4444 going on. Okay, the reason I did that is because I want the recurring digits lined up with each other. Because these are lined up with each other, if I take them away, these 4s cancel each other out. 100 take away 10 is 90. 4 take away 0 is 4. 90x equals 4. If I solve that now, x equals 4 over 90. Or if you simplify that, it goes down to x equals 2 over 45. Next one, 3 points for that one. Okay, I got 64 to the power of negative 2 over 3. Okay, 3 rules going on. Okay, the first one is the negative rule. I'm going to do them one at a time. It's up to you in which order you want to do them. The order I do them, though, is usually the one that will make it easiest for you. The minus rule is just you do the reciprocal. What the reciprocal means is you do 1 over whatever number you're dealing with. So instead of that minus, I'm going to take that away. I'm going to use it. So I'm going to have 1 over 64 to the power of 2/3. Okay, now I'm going to do the one on the bottom. The one on the bottom means cube root. Okay, the one on the bottom of the fraction. It means cube root because it's a 3. If it was a 2, it means square root. Cube root, so I'm going to cube root 64. What number times by itself 3 times gives you 64 is the number 4. So my answer is 1 over 4, all squared. And then if you square it, it's just 4 times 4. So my answer is 1 over 16. Okay, the square is just a normal squared. Okay, 1 over 16. That's 2 points. A bit of surds, okay, so this is just FOIL with the rules of surds kind of chucked in as well. Okay, very straightforward. Okay, first two numbers, 6 times 7 is 42. Outside edges, 6 times 5 root 3 is the same as doing 6 times 5 and having root 3 on the end. So 6 times 5 is 30, so my answer is going to be negative 30 root 3. The root 3 kind of acts like an x value. On the inside edges, 7 times 7 is 49 root 3. And then the last two, this is where it gets slightly complicated. 7 times 5 is 35, so negative 35. Root 3 times root 3, they cancel each other out. So what happens is it's 35, root 3 times root 3 cancels, 35 times 3. Minus 35 times 3 is negative 105. Okay, once you're there now, you can put it all in one line, exactly the same as you would if it was expanding a normal double bracket. 42 minus 30 root 3 plus 49 root 3 minus 105 on the end. Okay, once I'm there, I can put certain bits together. Okay, the 42 and the negative 105 go together, and the two middle bits also can simplify as well. Okay, so I've got 42 minus 105. I think that gives you negative 63. Then minus 30 root 3 plus 49 root 3 is the same as doing minus 30x plus 49x. Okay, it just gives you positive 19 root 3. Shh. So that's your final answer, okay? Minus 63 plus 19 root 3. Right then, so bottom left now, a bit of trigonometry, okay? Just kind of fly through these as fast as I can, okay? I know it's taking a while. The higher tier starters are quite chunky, okay? So obviously it's going to take a little bit longer. Okay, so on my opposite first, then I got my hypotenuse, then I got my adjacent. If you're ever doing trigonometry, always do those steps first. Once you've done those, I'm going to write down SOHCAHTOA. Okay, I'm looking for x, so I'm looking for my opposite, and hypotenuse has got 7, so I don't need adjacent, so I'm also going to cross out adjacent over here. The only one that's got all 3 still attached is SO. Okay, I want to find what x is. X is O, so I can write x equals. Now the bit you're trying to find, I always cover that with my thumb. Okay, if I'm covering that with my thumb, whatever's left is my working out. So my working out is sin times h, sin 27, times by whatever h is 7. Put all that in my calculator. Gives me 3.2 centimeters. Right, last two, very quickly, okay, because I want to fly through this. Okay, simultaneous equations, again, you've got to make the y's the same. You could make the x's the same, but I've always found making the y's the same is loads easier. Okay, so I'm going to times the top by 2, I'm going to times the bottom by 3. Times in the top by 2, I end up with 10x plus 6y equals 118. Times the bottom by 3, I end up with 9x plus 6y equals 120. Now, take those away from each other because the signs are the same. If you take them away, the y's will disappear. 10x take away 9x is 1x. 18, these take away and make nothing. 118 take away 120 is negative 2. So x is minus 2. Because I know x is minus 2, I can substitute that back in the top one. If I put x is minus 2 back in the top one, 5 times minus 2 is negative 10. Plus 3y equals 64. Okay, add 10 onto both sides. 3y equals 74, and then if you divide through by 3 to both sides, it doesn't give you a nice answer, but y equals 24 2/3. Last one, h is directly proportional to b when h equals 3, b equals 10. For an equation in terms of h and b, okay, if it's directly proportional, it's h fish sine b, okay, h equals KB. Now K is the bit we want to find. K is the constant that's going to link the H and the B for us. Okay, H is 3, B is 10, K equals 3 over 10. Okay, if K equals 3 over 10, my equation is going to be H equals 3B over 10. Now it says find the value of H when B equals 30. H equals 3 times 30 all over 10. 3 times 30 is 90, divided by 10 is 9. So when when B is 30, H has got to be 9. Right guys, add those up. If you got 18, that's brilliant. If you get anywhere over 15, that's also really good. Right, moving on to what we're doing today. So, we're only moving on quite quickly because we've taken a long time on the starter. Now, these are all the main rules that you need to know. Okay, I've done them on one slide, okay, only because it'll make it easier to copy down, okay. I would get them down, start getting them down now. So the first rule is really important, okay. So we've got angle at the center is twice the angle at circumference. Now these two are the same rule, okay, they just look slightly different. What I'm saying is when you've got an arrowhead shape, and that's the important bit, when it's an arrowhead shape, the angle at the center is twice as big as the angle at circumference when all 4 sides are touching the edge of the circle. Very straightforward. The next one, I'm going to number them. That's rule number 1. Next one, angle made by the diameter, obviously attaching to the edge of the circle, makes 90 degrees. So that's rule number 2. Rule number 3, this is an important one that comes up loads, okay? Opposite angles in something called a cyclic quadrilateral. Now what a cyclic quadrilateral is a quadrilateral, a 4-sided shape, but all 4 sides of the shape touch the edge of the circle. Opposite angles in a cyclic quadrilateral always equal 180. Exactly the same as kind of you would on a straight line or a triangle. They equal 180. So if you've got one and you're missing the other one, 180 to take away the one you're missing, take away the one you have, we'll find the one you're missing. Down by here, angles touching the same arc, and we call this number 4. Angles touching the same arc or a chord in the same segment are equal. So two angles are touching the same arc by here, they're equal. Same thing over here, okay? All of these rules will make sense when we do examples in a minute. Next one, angle between the tangent and the radius. So when the tangent touching the edge of the circle meets the radius, it makes a 90-degree angle. That's going to come into account as well. And the last one, number 6, alternate segment theorem. This angle by here is equal to that angle by there. And this angle by here is equal to that angle by there. Right, guys, I'll give you 1 minute just to get all those copied down neatly. Okay, and then we're going to move on to some questions. Right, guys, so I'm going to move on now. If you didn't get them all down, don't worry, this video is going up straight after the session anyway. It's just, it makes them easier to remember if you've got them written down. Now, actual examples, okay? Number 1, this is the one we saw right at the start, okay? This is the one where the angle at the centre is double the angle at the edge. And you have to write that down. So the difficulty with circle theorems is not actually finding out what the number is, it's remembering the rule. Okay, so you'd have to write down A is obviously going to be double 30, so A is going to be 60 degrees. And then if it was in the exam, you'd have to write down angle at the centre is double the angle at the circumference. You'd have to write those exact words down. Same thing for number 2. Although they don't look the same, they are the same question, okay? Angle B is just moved over the edge of the circle. So B is half of 86, or 86 is double B. So B would have to be 43. And then you'd have to write down that same rule. This one over here, we did this was easy. Angles touching the same arc are equal. Okay, so C would be 42. Because you can see the C by there and 42 are on the same arc. Same thing with D. Oh, a highlighter. Same thing with D and 31, touching the same arc. So C is 42, D would be 31. And then over here is one of the, I think it was the 4th rule we did. Okay, angles, opposite angles on a cyclic quadrilateral equal 180. So F equals 180, take away 1, 2, 3, which is 57. Okay, and E, opposite angle is 82. E is 180, take away 82, which gives me 98. Really straightforward actually when you put them into practice. The problem comes when you just got to remember them all. That's when it becomes difficult. And number 5, this is probably the most difficult one that people struggle to remember. Okay, alternate segment theorem. What that means is the ones that are equal is 45 is equal to n, and P is equal to 60. Okay, so I've coloured it on for you just so you can see which ones are equal. Okay, once you know that, I know n equals 45, P equals 60, and Q you can work out because you go back to year 7 rules. You can see angles in a triangle. So 60 take away n was 45, So 60 and 45, take away from 180, gives you 75. Okay, maybe worth writing those down. Okay, those are examples for the day done. And then we'll move on. If you 1 minute to write those down, if you don't think you have time, write some of them down, then write them down fully after the session. Right then, guys, so let's get on to some questions, okay? Right, so first one. Okay, let's have a go at this one. Okay, calculate the size of angle of the reflex angle AOB. Now be careful with the word in there, reflex angle they've asked for, not the normal angle, they've asked for the reflex one. So be very careful of the wording. Give you 60 seconds to get that done. You don't have to draw it out if you don't want to. Right then, guys, so going through this one quite quickly, okay? Reflex angle AOB. The one I can work out quite quickly is the normal angle AOB. That's easy, okay? That's the angle at the centre is double the angle at the edge. So that one by there would have to be 37 times by 2 to give us 74. Really easy. The one they want, reflex, remember, if you think back to like year 7 and 8, that's that one. They want that angle, AOB. Okay? That angle AOB would have to be 360, take away the 74 you just worked out. So that angle AOB would 286. And that's a good example of what a GCSE question would look like. So you've got to be careful with the wording. An actual GCSE question would look like this, okay? An actual higher tier one would look like this, okay? So have a go at this one in front of you, okay? You want to prove, they want you to prove that this is an isosceles triangle. Give you 2 minutes to get that done. Right then, guys, so very quickly going to go through this one, okay? I'm going to take my highlighter first just to show you alternate segment theorem comes into play again on this one. This one by there is the same as this one by here. Okay, and if I change the color now to a red, this one by here is the same as this one by here. So we can see that alternate segment theorem, the way it works. So you can say BAY equals BCA. So this one in here would be 74 as well. This one down by here would be 53 as well. And you can say as a reason alternate segment theorem. Okay, when it says it wants you to prove it's an isosceles triangle, you need to work out the missing angle by here. That angle by there is 180. Take away 53, take away 74. Which leaves you with an angle of 53. So if that's 53, and that's 53, okay, and obviously for this one, you'd have to say angles in a triangle added to 180. Two angles of 53, therefore it would be isosceles. Okay, but you've got to make sure you get your rules right. I'm not doing them because I've got such fat fingers, and it's hard to write stuff. Okay, right guys, last one, then we stop. The very last one of the day, then we're done. Find the size of angle OQR, that's this one in here. Call that angle X. Last minute on this, guys. Right then, so loads of rules going on, okay? I want to find this angle in here first. That's the angle I want to find first, only because this makes an isosceles triangle. The two radii and the chord always form an isosceles triangle, okay? So X and down by there, those angles are equal. Because if I can find the angle by there, I can do 180, take away that angle, and divide by 2, and that'll give me X. So in order to find that angle by there, what I've got is a four-sided shape. Okay, I've got a kite. Okay, now I know the tangent, where the tangent meets the radius, it makes a 90-degree angle, and that's another angle. There's another angle rule you'd have to write down. Where the tangent meets the radius, it makes 90 degrees. Okay, because of that, I can do 360, take away 90, take away 90, take away 30 to find out what angle the one right at the center is. That's going to be 150. If that one in the center is 150, okay, I can do 180, take away 150 is 30, and then divide 30 divided by 2 to get 15 degrees for my angle X. But you'd have to say your rules as you go through. You'd have to say where the tangent meets the radius, it makes it 90 degrees. The two radii and the chord make an isosceles triangle, and angles in a four-sided shape add up to 360. You would have to say those as you go through. Guys, I'm really proud of you. Well done for all your hard work, and have a lovely weekend.